All right, welcome to Chemistry 1127, Acids and Bases. Actually, I think this unit is probably one of the most practical, okay, in the whole chemistry course, because all the way through life, you are going to be dealing with acids and bases. A very common acids are even found in your kitchen. Vinegar is an acid, and common base is toilet bowl cleaner. And other types of strong cleaners have lye in them, which is a base. Other ones in the house, they try, they neutralize them so they're not too strong that they would really hurt you. Your dad may have out in the garage. You might ask him if he has in the basement or garage a chemical that's used for cleaning concrete, cement, and that would be sulfuric acid. This particular chapter about acids, we're going to talk about acids on pages 1 through 10. There are a lot of really cool videos. If you go on YouTube and just search for acid experiments and see some of the cool things that maybe you can't do, but you can watch someone else do. But one that I know even my students, when I've done this in the past, think is fascinating is to take an egg and put it in acid, like a strong vinegar. If you have sulfuric acid, do a little bit of that mixed with water, and you put the egg in there and let it sit for a while and keep spinning it, and all the eggshell will totally come off of it, and all you'll be left with is this rubbery ball. So look for a video on how to do that. That's kind of a fun one. This paste, honestly, wow. I've said this before, but what could be a fun and just kind of let's enjoy this paste, they throw so much terminology in here and things that honestly, as I'm teaching chemistry, I never even touch on. And I think I had it when I was in college, so maybe it's good to be familiar with some of these things, but there is so much stuff as you read through here that your head's going to spin and you're going to feel like there's no way I'm going to master all of this. So here's an encouraging thought for you. Number one, this is not a bad thing to do with every paste. I want you to go to the self-test, okay? This is not cheating. This is actually a good study technique. And if you look at the self-test, you'll see on page Z, list the properties of traditional bases, ways to prepare salts, and then question 23, list the properties of traditional acids. And there are A through F. So when you are reading about that, traditional acids in your paste, zoom in on that, realize, wow, I got to know this for the paste test probably too, because it's on the self-test. It's on the checkup as well, okay? And as you look at the questions on page Y, a lot of the content that you read about here in pages 1 through 10, they filter out, and all that shows up on the self-test, and therefore the paste test, is the stuff that rises to the top, the really important things, okay? But honestly, they put a lot in there that you don't need to master. So don't get frustrated. You're working through it. I don't understand this. This terminology is confusing me. Okay? Do your best to just look at the answers in the paste, fill them in your workbook part. Okay? And even if you don't totally understand it, it's okay. Score it. Study for your checkup. Memorize some of the content, even if it's not totally getting through your head, because a lot of times the purpose of a course like this is called an introduction to chemistry. This is not to make you a chemist, okay? This is to introduce you to concepts that if you do decide later to go into science and chemistry in college, you have a foundation. You'll say, I think I remember reading about that before, okay? Oh, now I get it. But as a teacher, I know that sometimes we have to plant an idea now that later will make sense, okay? And bring about the fruit of knowledge. But right now, don't stress, okay? That being said, let me just highlight a couple of things that I want you to know before you read the section about acids. To me, the key is this definition that an acid is a proton donor and it has something to do with hydrogen, and I want you to see why. It's not donating just a proton, It's actually donating a hydrogen ion. Now let's think about this. Hydrogen is the first element. It has one proton and one electron. If it becomes an ion and the electron is gone, okay, then we have a hydrogen ion, which actually is just a proton. Does that make sense? All right. So they're not saying something different. It's not like sometimes they're saying it's donating a proton, sometimes they're saying it's donating a hydrogen. Hydrogen basically is a proton if the electron has been taken away. So it's the same thing. All right, so that to me helps. Secondly, when you look at the list of most acids, and they give you a whole lot of them in your PACE, and again, you do not have to memorize all of them. They have a section where they say you need to memorize these. No, you don't actually have to memorize them. But notice what all these acids have in common. They all start with H. That's a clue that it is an acid, okay? If we were to take an acid, like let's take HCl, hydrochloric acid, and we added it to water, what happens is this hydrogen here separates from the chlorine and bonds to this, oops, I meant to keep this together, H2O, and we end up with something called H3O, okay, and chlorine. And the H3O will have a positive, it'll be an ion, but that hydrogen bonds with it. This is called a hydronium ion. We're going to find out about that as you read through the PACE. That hydronium is an indicator that we have an acid. The more hydronium ions that are produced, the stronger the acid. I guess I should have put a plus here, okay? Here's another very common reaction. In fact, I try to do this with my chemistry class every year. Sodium hydroxide is actually a very strong base. We know it's a base because it has OH in it. And this is an acid because it has the H in the front, okay? So hydrochloric acid and sodium hydroxide, you mix the two together in exactly the right quantities and all of it reacts and you end up with water, and this is a salt, sodium chloride. It's actually just table salt. So I don't recommend you try this at home because here in school I can do it with lab equipment and make sure that I'm titrating it to get the exact amount. But if I titrate exact amounts of these two together, I'll have just salt water. And you can literally drink it. Now, it tastes like salt water. It's not fun to drink, but it's literally just salt water. All right. So this, we mix any acid with any base. One of the main reactions that happens is it produces water and a salt, and that is called a neutralization reaction. Maybe you remember that from a previous PACE. Now there are other types of reactions, there are other types of acids and bases, and honestly, there's so much content in here that they cover real quick. There's a lot of history, a lot of terms. They talk about different types of acids. Some of that, I guess you need to know. But this is the most common type of reaction. Then I just want to point out one more thing before I end this introductory video. And that is that some types of acids, when they break apart, will only have one hydrogen that's given off. That's called a monoprotic. Protic means protons, which remember is hydrogen. Okay, so monoprotic, and then if it can give off 2 or 3 hydrogens or protons, are called polyprotic. Okay, polyprotic, giving off more than one, and that actually makes them like a stronger acid. Okay, because they can give off more hydrogen as they are mixed with water and put into a reaction. Okay, so anyways, I'm just trying to give you a big bird's eye view. Whenever you're looking for an acid, look for the thing that starts with an H. That most often is the acid. All right, we'll come back and do a video about bases. And then at the end of this PACE, there is some math, a little bit of math, and we'll definitely help you with that, okay? But for this first section, read it, highlight some things, look at the self-test first, read the checkup, and then start working through the PACE. And I think it'll help you just breathe a sigh of relief that some of the stuff that's over your head you really aren't going to be held accountable for. Make sure you master the things that you do need to know for your upcoming tests, all right?